And the following week will be the week that I open up the old adaptives for people who needed to for people who didn't do any of them or something like that and wanted half credit. So the stuff that was due April 8th, I'm only partway through changing the due date on that. So if you don't see the due date on that change just yet, don't worry about that. I just, class started. I figured I probably ought to show up today. It's probably a good thing. It'd be hard to have class without me. Not to say that you couldn't, though. You probably could. All right. Am I dropping? Yes, I'm dropping one set of homework. Dropping one set of adaptives, one set of homework, 2 quizzes. Yeah, I think that's pretty much all we have. Yeah. Nope, not dropping an exam. But unless I've spoken to you about something, and most of you this doesn't pertain to, then the lowest test score will be replaced by whatever you get on the final, the raw score, so the uncurved score, will replace it if you made higher on the final than the other one. So, yes, you're getting extra credit for those. I just keep forgetting to send it to you, which is just plain sad. So I'll try to do that today before I forget. So, yeah, the final will be curved. Final's always curved. They're going to be great. I spent the last few days going through the videos, the webcam videos. Oh my gosh, there were a ton of them. I finally finished, and I contacted everybody I needed to. So, done with that. I think next time, probably I'm just going to randomly choose some videos to check. I might check all of the people that were like high risk, or maybe every third one or something like that. So I don't know. But yes, they will get graded. I have looked at some of them. I just haven't put the grades in yet. So, yesterday I spent trying to grade my stuff for something else. So I still have one person who hasn't taken it yet, so I can't do that yet. Oh wait, for exam 2, yes, I can do exam 2. What do you mean? Can you please add the wrong questions like exam 2 at exam 4? You will get extra points for exam 3. I'm not sure I understand, Chris, I'm not sure I understand. It says, can you please add wrong questions like exam 2 at exam?
She's like,
hey.
She's like, I think they're trying to say like, for the second attempt, you can only show like the wrong answers we got.
Oh, yeah. I'll consider it. Maybe not. So I have to think about it. I'll take a look at the grades that you guys got this time and see which way we need to go with that. All right, and then I'll let you know. Yeah, because the main reason I do the second attempt is just in case something goes wrong with the lockdown browser, more than to give everybody an actual second attempt to take the whole thing again. But if you get lucky and you finish in like 20 minutes, you're always welcome to take the second attempt. But I'll think about that on the other one. So, let's see. Would it be completely unacceptable to do the extra credit from the last test today? Email the reasoning why I couldn't do it. If you have an excuse like a doctor's note or something really big, then I can work with that. Let's see, for exam 4, can we have the formal exam review outside of lecture? It was way more helpful than class. We'll see. And then was there an extra credit? There will be, but I haven't assigned it yet. Okay. All right, so today we're working on combustion analysis, which is pretty similar to what we were doing Wednesday. It's just one more step. So it's more stoichiometry stuff. So that was a lot of questions, Roger. You are right. So let me go ahead and share, or I know, I've only got like half an hour. We just started. Okay, so I'm gonna move this over to the other computer. Come on. And let's see if I can make this a little larger. And then, where's my mouse? For crying out loud. Okay. So if you want to find notes on combustion analysis, they're in the same notes that we were using for percent composition and stoichiometry. They're just kind of at the end. So combustion analysis is, let's say you have some sort of compound, you don't know what it is, and you want to try to figure that out. Combustion analysis is one way to do it. So let me give you an idea of what that means. Come on. Okay. So let's say we have a hydrocarbon. It's made out of carbon, hydrogen, and in this case, carbon, hydrogen, and oxygen. So a lot of times they're just carbon and hydrogen. So let's say we have this, and we burn it in the presence of oxygen. I don't know why I'm making that a Z. That is a 2. Sorry about that, guys. Okay, and then I get carbon dioxide and water. And you do need to know that combustion of a hydrocarbon gives you carbon dioxide and water. All right, and I am able to figure out how much of this I have. So I'm given the mass of this, and I'm given the mass of this. And that's all I'm given. Because this is going to be, it's burning in air, so that's the oxygen in the air. You can measure the oxygen in the air that burns with it. I mean, you can figure it out, but it's kind of harder to measure that. So this is unknown. And this may be unknown. But yet, you can use this information to figure out what the molar mass is. Well, sort of. You would need a little bit more information to get the molar mass. But to get the empirical formula, this is all you need. So I put in a lot of questions that were hopefully relatively easy in the quiz. So 2 of them hopefully made no sense to you at all. And then 1 of them made sense. So the one that says you couldn't figure it out at all, that one's wrong. And then the one where I said something like convert grams of carbon to grams of carbon, because you don't know how much oxygen you have or something crazy like that, those were all wrong answers. So let me show you kind of how to work a problem like this. So let's say we have this, and I'm thinking, okay, in this case, let's say that this is known. You don't have to know this to get the empirical formula. So let's say this is known. Let's say we have, let me change color here. Red is such an angry color. Okay, let's say we have 0.8233 grams of some hydrocarbon, which is made up of carbon, hydrogen, and oxygen, but we don't know the formula yet. So we're trying to figure that out. And once we burn it and weigh it, then we're going to have 2.445 grams of this and 0.6003 grams of the water. So this isn't how it is every single time. Like, you'll get a different mass of carbon dioxide and water depending on how much hydrocarbon you use and which hydrocarbon you use. So we can use this information. This is all we need in order to get, oh my gosh, that's bizarre. My computer's acting really weird. Come on. Oh, for crying out loud. I'm just going to let it be. I can't see the comments right now. I can only see part of the comments. Part of my screen is turned black. I'm not sure what that's all about. Maybe if I... No, that has nothing to do with it. Let me see. Give me 1 second. Let me see if I can figure this out. It's going to drive me nuts. Why? No clue. Okay, so just, if you've got a question, you're just going to have to unmute and let me know, because I can't see. For some reason, I've got a black bar that's covering up all the comments except for like the first 3 letters of the comments. So sorry about that, guys. Okay, so to do this, all I need to do is find out basically how much carbon, how much hydrogen, how much oxygen. Because remember the steps to find empirical formula? It's convert to moles, and then divide by the smallest moles, and then, make sure you have whole numbers. And then there you go. There's your formula. So, you can break it down into more steps if you want. But this is a general idea. Just figure out how many moles of carbon, how many moles of hydrogen, and how many moles of oxygen. So if all I have in here is CHO, burning in oxygen, and I produce carbon dioxide and water, what happens to the carbon from CHO? What does it turn into? And you'll literally have to unmute because I can't see a thing.
All of it turns into CO2.
Yes, all of it turns into CO2. And from CO2, we know the mass there. We have the subscripts of CO2. So we can figure out how much of that we have, right? We don't have to balance this equation yet. You can't balance this equation yet because you don't know how many carbons you have, or hydrogen or oxygen, in the hydrocarbon. So the first thing to do is convert all of your carbon dioxide to grams of carbon. So I'll show you how to do that. We're going to go grams of carbon dioxide to moles of carbon dioxide to moles carbon to grams of carbon. Oh, actually, we don't need that last step. I just got a little carried away. All right, and then hydrogen, all the hydrogen is found in the water because it's the only thing that we have on the right that has hydrogen in it. So all of the hydrogen has to have been put into the water. So I'm going to convert my grams of water to moles of water to moles of hydrogen. And I was about to just keep going there. And I'm going to stop. Then I have to figure out how much oxygen. This is a little bit more tricky because you have oxygen from the hydrocarbon here, but you also have oxygen from here. We're only interested in the oxygen from the hydrocarbon. So what we can do is find out how much oxygen we have total on this side. And then when we figure that out, we can subtract it from, we can subtract the oxygen from the total amount, and then that will just give us what we got from the hydrocarbon, if that makes sense. So then we're going to do grams of CO2 to moles CO2 to moles of oxygen, and then grams of water to moles of water to moles of oxygen. And then what we can do is we can, actually, I don't think you even have to do that. There's an easier way to do this. You should be able to, this will give you the amount of oxygen that you end up with in the end. But what you could do is, since you have carbon and hydrogen and oxygen, that total minus the amount of hydrogen plus carbon gives you the amount of oxygen you have, right? So these steps you can actually skip. And then once you have grams of oxygen, then you just convert to moles of oxygen, and then you're good. So I'm going to give you guys, does anybody need a second on this? If you put a Y in the chat, I can see the first letter. So if you need a second, just put a Y, and if not, put an N or. Okay, so I'll give you a couple of seconds on this, and then we're going to work this whole problem, because I'm sure at this point you might have a kind of blurry, sketchy idea, but my explanation was a little, it could have been better, so I'm going to make it better. The last comment, all I see is SM and W are maybe O. Can somebody unmute and tell me what that says? If you don't mind.
Someone said that smart works, homework, sometimes it's wrong.
Not terribly surprised. If you find one that's wrong, just email me that one, and then I will try to figure out if they put the wrong answer in, and then I can grade credit for that.
Professor, I'll tell you.
I saw the XM.
Oops, sorry.
Oh, go ahead.
For SmartWorks, I think I know what Chris is talking about, because it'll tell me it's wrong, so I have to put in like a different number past the decimal. I've had that happen a couple times, so it's just super picky, so you have to play around with it.
Yes, it will probably mark you wrong if you're not using the correct significant figures. That it would do. It'll also mark you wrong sometimes if you don't put in a capital and you needed a capital and put in lowercase. It is real picky. It's a big pain behind. But okay, so let's go ahead and work this problem. All right. Okay, so the first thing we're going to do is we're going to take our carbon dioxide and we're going to convert it to moles of carbon. And it said we had 2.445 grams of carbon dioxide. All right. And then when we calculate the molar mass of carbon dioxide, it would be 1 carbon, which is 12, plus 2 oxygen, which would be 16 apiece, so that's 32. So the total is 44, and I'm going to use more decimals this time. You don't have to, you can. Grams of CO2. Actually, when you're doing SmartWorks, you probably should use the extra decimals because it is picky. All right, and then what can I use to figure out how many moles of carbon there are in carbon dioxide? And you'll have to unmute to tell me this.
Molar mass.
Well, the molar mass, we use the molar mass here, so that's how many moles of carbon dioxide we have. So that's correct. And how do we go from moles of carbon? Yeah, the ratio. Moles of carbon dioxide to moles of carbon is just using the subscripts, right? So there are 2 oxygen for every 1 carbon. So that would be 1 mole of carbon for every 2 moles of oxygen, or 1 mole of carbon for every 1 mole of carbon dioxide. All right. And so that's going to give us moles of carbon. So somebody figure that out and let me know what that is. And I'll be setting up the next part. Anybody figure that out? Let's see if I can do that. Oh, actually, I've already done it. Just like
It's 0.05 repeating.
Yeah. Okay, so that's how much carbon we have. And then for the hydrogen, we have, to start with, it tells us how much water we ended up with. So we're just going to convert that to moles of water and then moles of hydrogen. So the molar mass of water is 18 because it's 16 from oxygen and 1 for each hydrogen. So that's 16 plus 1 plus 1. So it's 18 grams of water for every 1 mole of water. All right, how many moles of H are in 1 mole of water? 2. Good. All right. So when we put that in the calculator, we get 0.06662 moles of hydrogen. So then I've got that part. And so the next thing we need to do the empirical formula is just find out how many moles of oxygen we have. But we can't do that without also figuring out how many grams of carbon and how many grams of hydrogen, because it tells us that our hydrocarbon weighs 0.8233 gram sample of some CHO thing. So if I subtract the carbon and I subtract the hydrogen, I will just be left with the oxygen. Then once I figure out how many grams of oxygen, I can just convert that to moles. Then I'll have moles of carbon, moles of hydrogen, and moles of oxygen. All right, so we'll do that real quick. So we've got 0.05556 grams of carbon, and then something like 12.01 grams of carbon, 1 mole. No. Let's not do it backwards, right? Let me try that again. I was just kidding, right? 0.05556 moles of carbon. We're going to go to grams. Okay, 1 mole carbon, 12.01 grams of carbon, and that's going to equal 0.6673 grams. Okay, so now we've got the carbon. Anybody need a second on this before I do the, I've got to clear this so I can do the water. Nope, okay. Chad, what's your question?
So, for the second conversion with water, I typed all of that into my calculator and got like 0.06667. So, how did you get that other answer?
I think actually I used 18.02 instead of just 18, and so that would change it just slightly.
Oh, okay.
Yeah, but it shouldn't change it enough to matter a whole lot. All right. All right. So we had 0.06662 moles hydrogen. I'm going to convert that to grams of hydrogen. And what's the number I used for that? Okay, 1.008 grams of hydrogen in 1 mole hydrogen. This is the molar mass, by the way. All right, and that's going to give us 0.06715 grams of hydrogen. Right? And we had already calculated that we had 0.6673 grams of carbon. All right. So knowing that, and knowing that we had a total of our initial compound, which was our sample, was 0.8233 sample of carbon, hydrogen, and oxygen. So all the carbon is going to turn into carbon dioxide. All the hydrogen is going to turn into water. Where we're able to figure out how many grams of carbon were in carbon dioxide, how many grams of hydrogen were in the water. So if we subtract the carbon and the hydrogen, we're left with just the oxygen. 0.82233, this is the sample of CHO. We're going to subtract the carbon, which is 0.6673, and the mass of the hydrogen, which is 0.06715. And that is going to give us, so we will have subtracted the carbon, subtracted the hydrogen, and that will give us how many grams of oxygen are left. So that's going to give us 0.0889 grams of oxygen. So that's good. So now we know how much carbon, how much hydrogen, and how much oxygen. We've calculated moles of carbon, moles of hydrogen, and we're just going to figure out how many moles of oxygen to figure out what we've got there. All right. So does anybody need a second on this page? No? Okay. Oh, one person does. All right. Actually, I guess I could do the grams to moles at the bottom. I'm just going to do it in a different color. So it's 0.0889 grams of oxygen, 16 grams of oxygen. All right, 1 mole of oxygen. That's going to give us 0.00556 moles of oxygen. Right? So now we've already calculated on a previous page the moles of carbon and the moles of hydrogen and the moles of oxygen. So we are going to just figure out which one's smallest and that sort of thing. All right. So let me show you how to do that. All right. So I'm going to write the pseudo formula. So it told us that for our carbon, we had 0.05556 moles. For our hydrogen, we had, or it doesn't tell us that, we calculated that, 0.06662 moles. And for our oxygen, we just calculated that we had 0.00556 moles. All right, so our pseudo formula is going to look like this. All right, hydrogen 0.06662 and oxygen 0.00556. All right, so now our step is to figure out which one of those numbers is the smallest. So it's pretty easy to tell because 2 of them have the first number in the hundredths place. So that'd be the 0.055 whatever and the 0.066 whatever. And then the oxygen has it in the thousandths place. So it's got 0, 0, then a number. This one is 0, then a number, 0, then a number. So clearly this one is the smallest. All right, so for carbon, we're going to have 0.05556 divided by 0.00556. Hydrogen is going to be 0.06662 divided by 0.00556. And oxygen is going to be its number divided by itself, 0.00556, 0.00556. Okay, so we take the moles of each one and divide by the smallest amount. So for carbon, that's going to give us a 10. Hydrogen is going to give us a 12. To that, it might not be exactly 12. It could be like, 11.98 or something like that. All right, so then these numbers become our subscripts. So we have carbon, hydrogen, oxygen, and this 10 goes with our carbon, 12 goes with our hydrogen, and the 1 goes with our oxygen. That is our empirical formula. All right. And then if it wanted us to figure out the molar mass, not the molar mass, but the molecular formula, they would have to have given us the molar mass of this formula. They didn't. So since you don't have the molar mass of the compound, then you can't get the molecular formula, because if you take the empirical formula and you multiply the subscripts by some number, that gives you the molecular formula. And to get N, that's the molecular mass, or the mass of the molecule, divided by the empirical molar mass. Now we calculated the empirical formula, so we can get this, but this has to be given to us, or this has to be given to us. Something has to be given to us because we don't have enough information to figure it out otherwise. All right, any questions on that? No questions? All right, so we've got about 5 minutes. So I'm going to start introducing some solution units, which you guys probably already know a lot of those. But before I do that, does anybody need a second on this page? No? Everybody's good? Okay. Come on. There we go. All right, so we have molarity, and this was one of your questions, and that's moles of solute over liters of solution. So then that brings the question possibly, what is the solute and what is the solution? How do I tell which is which? Solute is usually in the smaller amount. Well, it is in the smaller amount. And the solution is everything. For example, if I had salt water, and remember, AQ means aqueous, so it means it's dissolved in water. So in this case, sodium chloride, and this says dissolved in water. All right. If I had that dissolved in water, sodium chloride is my solute, and then the solution is the sodium chloride and the water together. All right. So if they told me how much salt I had, and they told me how much water I had, I could do molarity, but I would have to remember to add my salt and my water together in order to get the solution. So moles per liter is molarity. And then let's see what else do I want to show. They did go over parts per million. That's equal to milligrams per kilograms. There are other ways you can calculate that as well. I think that's where we're going to leave it today. We're going to finish up with solutions on Friday. Yeah, we'll finish solutions on Friday. All of your homework will be due on Sunday. I'm not going to make it due on Monday because I want you to spend Monday studying for the exam and not doing all that stuff at the same time. All right, and I will see you guys on Friday.